Good day to you all. Learner's Note is an online solution to encourage better way of education to our students. I am Aiswarya and I will be your mathematics teacher for the day. So today I'll be taking up a very interesting topic, and that is nothing but direct and inverse proportions. So before going into this, I just want to talk to you about what is like proportion. Like you all might have learned about what's ratios, proportion. You guys would have really got bored about it. But I'm going to make interesting like these topics to you, especially what I'll be talking is about proportion. So I just want to say that proportion is an equation that's nothing but that says that two or more ratios are equal. Now what are these ratios? Now ratios are nothing but some fraction, like something of p by q form. So that's a fraction which can be equated to another fraction, and if one fraction is equal to another fraction, that's called as an equal ratio. And if they are equal, we say that they are an equal proportion. So it's, I think, as simple as that, right? So I have an example here for you guys. So just imagine that I have three balls right here. So you can see that one is yellow, two are blue. And so I'm going to ask you people, how many yellow balls are there out of these total three balls? There are three balls out of this, and how many yellow balls are there? I know that you guys would have already known the answer for it. Yes, it's like 1 out of 3, right? 1 ball out of 3 balls. So what is the ratio of it? So it's very simple, it's 1 by 3. Now I'm giving you another scenario where there are totally 6 balls, and I'm asking you how many yellow balls are there out of these total 6 balls. So there are blue balls also, right? So again you can just count. So there is 1 and 2. So this is nothing but 2 out of 6, which is 2 by 6. Now you guys will know about all your basic mathematics, right? That is nothing but this is equal to, so this is equal to, what is 2 out of 6 or what is 2 by 6? That is nothing but, if you cancel this is going to be 1, and it is 2 3s are 6, so this is going to be 3. So literally we have 1 by 3 is equal to 1 by 3. Can you see that these ratios are equal? So you can say that these two are exactly in same proportion, which is nothing but called as equal proportions, or nothing but normal proportion itself. So yeah, so 1 out of 3 is equal to 2 out of 6. How did it become equal? It's nothing but I just cancelled them. So it's 1 by 3 is equal to 1 by 3. So that's why we say they are in the same proportion. So can we move ahead? So yeah. So I have another example here for you guys, not just one. So I have like a rope right here, and you know that ropes are measured in length. So here there is like a rope which is of 20 meters, and I have another rope which is of 40 meters, and the weight is also given, not just length. So we have length, so we have length, and also we have one more thing, that is nothing but the weight of the rope. So the first rope, that is 20-meter rope, is of 1 kg. So you can see here this is 1 kg, and the 40-meter rope is of 2 kg. Okay, so I'm going to ask you guys, what will be the ratio of length is to weight of the first rope? So if I ask you, it's a ratio, so you know that's of a fraction form, that's nothing but of equal to 20 divided by 1, isn't it? Yeah. So next I'm going to ask you another thing, that is nothing but we have another rope right here which is a 40 meter. Again I'm explaining, that's 40, and it's of 2 kg. So I'm going to write the ratio again. So that's equal to 40 by 2. Now you guys would have wondered, like, why did I write this the equal to sign in between? It's nothing but I again can just simplify this. This is nothing but 2, that is 20, and this is 1. Can you see that we got it as 20 by 1, that's equal to 20 by 1 itself. So you can see that this is in the same ratio, or the ratios are equal, and that's why we call that it is nothing but equal to same proportion. So I gave you 2 examples. That was, one was a balls example, and that was another one is this one. So I hope you guys would have understood, if not the whole thing, but like little bit of it. So hope this helped. So let's move ahead with the next one. So yeah. Now, there are 2 kinds of proportion. I told you about like normal proportion, but there are 2 kinds of proportion. First one that we are dealing with is called as direct proportion. Now the word itself would have like given you some idea, right? That's nothing but direct. It's very direct to you. That means it's a normal proportion, but I just showed you the examples all were direct proportion. Like for example, the ball case, the 1 out of 3 balls you had, that is 2 out of 6, that was 1 out of 3 is equal to 1 out of 3 itself. That means it was a gradual increase, right? If one increased, the other also increased. So that is called as direct proportion. That's why it is written. It's a situation like where an increase in one quantity will cause a corresponding increase in the other quantity, and also it's the reverse for it. Like for example, I'm telling you that the number of balls like initially was some 20, and the next time I'm taking like some 3 balls out of it, so it is 7. So what happens is the decrease is nothing but gradual. So if one thing decreases, another thing also decreases. So that is also called as a direct proportion. So here the two important words you should understand is the increase in the quantity and the decrease in the quantity. So these two are the important thing when it comes to direct proportion. So increase is equal to increase and decrease is equal to decrease. That is called as direct proportion. Hope it helped you. So I have given you a picture for it. Like for example, this is giraffe, and giraffe was like a very small one, like who was just like growing. But then the giraffe like he'll not stay as it is. He'll like grow and grow and grow, and he reached up to this stage. So did you see that how the increase is? It's very direct, or basically this increase is direct proportion. So if like there is a change and the change is proportional, and if one thing increases, the other thing also increases. So this is called as direct proportion. So hope it got you too. So yeah. Next we have an example for direct proportion. I gave you another example that was of giraffes. Now this is another example for it. So we have a machine manufacturing unit, and just imagine that it manufactures like 20 units per hour. Now just imagine that 20 units per hour. So that means in 1 hour, like in 1 hour, it produced how many units? That's nothing but 20 units, fine. So we have 20 units in 1 hour, okay. So this is an example for direct proportion. So because I'm going to give you another scenario where if in 2 hours, like for example 1 hour it produced 20 units, and for 2 hours let's see how many units can it produce. So if in 1 hour it's going to produce 20 units, in 2 hours it's definitely going to be 2 into 20, that is 2 into 20 units, that's equal to 40 units, right? So can you see that the proportion here right is 20 by 1, that is 20 units in 1 hour, is equal to 40 by 2. And what is 40 by 2? You guys will know that it is nothing but it is 20 by 1 itself. Now can you see that the increase was like direct, like the increase in the hour also resulted in increase in the unit, right? So the increase in the hour or the time, basically hour is nothing but time. The increase in the time resulted in increase in the unit, and it's a logic that if you have like more amount of units to be produced, it takes more time. So that's a direct increase, right? So this is equal to 20 by 20, and that is nothing but 20 by 1 is equal to 20 by 1, or that's something 20 is equal to 20, and this is an example for direct proportion. So hope again this was clear to you. Yeah. So I'm going to, so I was just talking about the direct proportion, but I want to talk to you about how we can represent it mathematically. Direct proportion, how can we represent it mathematically? So direct proportion can be represented something like this: y is equal to kx, and here k is represented as the constant of proportionality. Now y is nothing but like a quantity, x is nothing but another quantity. If there is an increase in y, that is nothing but another same quantity itself. If there is an increase in y, there will be a corresponding increase in x as well. So that's as simple as that. And how much will be that increase? That is determined by this constant, like how much increase would or how much decrease. So this k can be negative or k can be positive. If it's negative, it means like a decrease in the quantity is having a corresponding decrease in the other quantity x as well, and an increase in this quantity will have an increase in this quantity x. So that's called as direct proportion, y is equal to kx. So this also I hope it helped you. So So now that we're done with direct proportion, I think you might will be wondering, like, what if, will there be a scenario? If there is an increase in one quantity, will there be a decrease in another quantity? I mean, that's like completely different, like it's opposite, right? Yes, there is a scenario like that, and here we have the picture for it. So I have given you a direct example, and I'm sure you as a children would have gone for like seesaws and all in parks, where you and your friend like sit across each other, and if you go down, your friend will go up, and if you go up, the friend will go down. So the same thing is happening here. That is, the increase in one thing will result in decrease in another thing, or the decrease in one thing will result in increase in another thing. So that's what is called as inverse proportion. So I just give you an example for it. Let's see how can we do it like mathematically. So this is an example for it. I'm sure you would have gone like in cars and not normal vehicles, you would have traveled, right? So speed and travel, or speed and time, can be considered as something which is like inversely proportional to each other. You guys will be wondering how, so I can just tell you. Suppose like you're going like to a place, and you're going like at a speed of, maybe I'm telling you, like 30, sorry, though we have, yeah, so 30 kilometer per hour. So this is the speed. So you know that speed is going to be measured in terms of kilometer per hour, because it's nothing but it's distance divided by time. So 30 kilometer per hour, and you're saying that you're going to that place at a speed of 30 kilometer per hour, and it takes you like say like 1 hour. Okay, I'm just giving you a very normal example. Just think that it's going to take like 1 hour. Now I'm giving you another scenario. You're going to that same place. I'm going to increase the speed now. So first it was 30 kilometer per hour. I'm going to increase the speed now, maybe to next time. So this is scenario 1, and this is scenario 2. Maybe I can tell you like 60 kilometer per hour. Fine. So 60 kilometer per hour is the next speed that you're going, the same place, exactly the same amount of distance, and also the same place you're going to travel in 60 kilometer per hour. So what happens is, I'll tell you, initially you took 1 hour for 30 kilometer per hour, but now I'm going to tell you that the speed, if you increase, the time that you've taken to reach that place is going to decrease exactly, and I'm telling you it will take you just 30 minutes. Or I can say 30 minutes to be nothing but equal to half an hour. Right? Half an hour. So this is an example for inverse proportion, that is, when one increased, the other decreased, and when the other decreased, the other one increased. It's an example for inverse proportion. So that is why I have given you this vehicle example, or the car example, where you take like more amount of speed, that means you will reach that place in less time, and like more amount of time, that means it will take like less speed. So that's the kind of inverse proportion example which I wanted to give you. So hope that it helped you. So yeah, so like I gave you a mathematical expression for direct proportion, which was nothing but, I hope you guys remember that it is nothing but y is equal to k into x. So I hope it you guys will remember that was a mathematical equation where y was one quantity and x was another quantity. Increase in one quantity will result in increase in another quantity, and k was the measuring factor which will measure how much amount of increase or decrease should be there. The same way I can give you a mathematical expression for inverse proportion as well. So inverse proportion, again I'm going to tell you, it is increase in one quantity will lead to decrease in another quantity. So if I write y is equal to, y is equal to k into x. It's very direct that if suppose this is equal to 6, this is equal to k into some 3. So that or basically 3k, whatever it is. So that means these both are like direct to each other. So that is not going to help us, right? So for us to logically take that, here I have given you y is equal to k divided by x. What do you mean by this? For example, if this y is equal to, suppose 10 is equal to y is equal to k divided by, suppose if it's like 2. So here 10 is y and 2 is x. So that means the increase in like this quantity, if there is an increase in this, definitely 2 is in the denominator. So this value is just further going to decrease. Suppose if this becomes 20, this will become half of it. So that is nothing but the increase in this will just result in decrease in this quantity because it is in the denominator. So that is why we have y is equal to k divided by x as the formula for inverse proportion for you. So like how y is equal to kx, the same way we have y is equal to k divided by x. So thank you. So hope you guys had a bit of understanding from what I taught you today. So today we talked about direct proportion and inverse proportion, or basically proportion as a whole. So what was direct proportion? Direct proportion is nothing but increase or decrease in one quantity is going to like result in an increase or decrease in another quantity. And what was inverse proportion? It is nothing but increase or decrease in one quantity is going to result in decrease or increase in another quantity. It's just the inverse of it. And then we also talked about mathematical expression of both of them. So what was the mathematical expression of direct proportion? So it is nothing but y is equal to kx, where y and x are two quantities and k is known as the constant of proportionality. And also, what was the mathematical expression for inverse proportion? It is nothing but y is equal to k divided by x. Like for example, like y is increasing, x is going to decrease because x is in the denominator, and if x is going to increase, y is going to decrease. So because x is definitely in the denominator. Learner's Note believes in learning concepts by learn by doing methods. So you guys can watch these videos online and visit us at www.learnersnote.com to watch such fun, more exciting videos. So hope that we had like a wonderful session and you guys like literally understood each of it. And so today I'm signing off. I'm your mathematics teacher and I'm Aiswarya. So see you, keep watching the videos, have fun. Thank you.